Okay, just a little bit of an update on this Advent of Code Problem 5 Part 2 graph, basically a graph problem. I mentioned how I had picked out one particular line of page ordering data and looked at all the ordering data that was applicable only to those nodes and turn that into a graph where we could observe the connections, directed connections between the page 12 has to come before 11 and 44 and 43 and 64 and 74, and so I had narrowed these connections, rules, I guess they call them. Really, they're graph edges, down to this node base, but I wanted to list them out by node, so I added a little bit of extra code here just to go through all the narrowed down edges, of which there is like a repeating of the first element can repeat several times, and just for each element to build up a list of things that rule is connected to, and it comes out looking like this, for example. There are this was the very first line. There are 13 numbers mentioned, 13 nodes, and there are 12 here that have data about pages that must come after, which therefore means, okay, this 93 doesn't appear in this list. It has to be the last page of which nothing comes after. And then I started to sort of rearrange them a bit, and I noticed that I didn't realize the data actually necessitated that it would tell you everything that came after. I think it was a harder problem where it would only tell you kind of locally pages that must come after, but this makes it a bit easier actually. We know everything that must come after any particular page. That wasn't clear to me beforehand, but it kind of suggests how to then unwrap the, well, I guess that automatically kind of unwraps our ordering problem, because we would just start from the bottom here where everything comes after and move our way up, having to add 93 on the top of it, and that's our ordered list, now that I think about it. But this also makes sense of a really great YouTube video, consistently great YouTube video, by Connor Hoekstra, Code Report on every social platform, I think. He's interested in BQN, APL, Weaver, Jelly, as well as C++ and Python, and lots of Haskell and all that sort of thing. Lots of languages, and he describes a solution that he didn't come up with personally to this problem.
And what we have here, as mentioned, is a partially applied members of with make pair. And if we go to our command line and type bqn test, we're going to need to zoom out a bit on this. This is what we're getting from this. So,
and this suddenly makes, I had listened to this video in the car, I hadn't really caught the detail of what these upper triangular matrices were all about, but now that I've done this other text figuring out that I just showed you, it's like, I think it's all going to make sense now. Talking about finding out basically for every node in the list which ones necessitate having all the other particular ones that must follow after them. Anyway, that was just a quick update and very interesting. Check out Code Report channel. It's fantastic stuff. It's always been great, and